All right, AP Calculus, today we're going to find infinite limits and limits to infinity. So the first thing I want you to do is go ahead and pause this video and complete the warm-up. Okay, now check your answers and make sure that you're good to go. All right, so the definition of a vertical asymptote is when the limit does not exist, when the limit's going to infinity or negative infinity. And the definition of a horizontal asymptote is when the limit approaches negative infinity or infinity, then you're approaching a certain number L. So a little side note, limits to infinity are about the end behavior of the graph. That's why a horizontal asymptote, sometimes you may have noticed that a horizontal asymptote like we have here, that the graph will go through it in the middle, and that's because the definition of a horizontal asymptote is not that the graph doesn't touch it anywhere, it's that the end behaviors of the graph are approaching that number. The ends are approaching that number. So that's what we're doing today, are those types. So when we're looking at limits, we can, if they are going to infinity or negative infinity, we can say that does not exist. But if we can be more specific, we want to. So if we look at A, the limit as x approaches 1 from the right is here. So this side's going up to positive infinity. From the left, also going to positive infinity. And so we can say that the limit as x approaches 1 goes to positive infinity. Now, if we look at part B, graph B, as we approach 1 from the right, we're going to negative infinity. As we approach 1 from the left, we're going to negative infinity. And therefore, we can say that the limit as x approaches 1 of f of x is negative infinity. Now, if we look at part C, the limit as x approaches negative 3 from the right, that is going up to positive infinity. But the left side is going down to negative infinity. And so we can say that the limit as x approaches negative 3 from the right is infinity. From the left is negative infinity. Therefore, the limit as x approaches 3 does not exist. So how does not exist work if we're doing things algebraically? So the first thing we do is direct substitution. And if we get a result as a number over 0, that means there is a vertical asymptote there. And so the arrows are going to infinity or negative infinity. So in number 1, if we plug in 1, we're going to get 1 squared minus 3 times 1. So we're going to get negative 2. And on the bottom, we're going to get 1 minus 1, which is 0. So we're going to have negative 2 over 0. And so we know this limit does not exist. However, since we're approaching 1 from the right side, we can actually be more specific here and try to figure out exactly what the graph is doing. And so we know at 1, there's a vertical asymptote. And we want to know what the graph is doing on the right side, to the right of 1. So we're going to look at this side. And so we can real quick just make an XY chart and plug in points 2 and 3 to see what the graph is doing. So when x is 2, we have 4 minus 6, which is negative 2. So we have 2, negative 2. And then when x is 3, we have 0. So 2, negative 2, 3, 0. And so if we connect those and then head towards the vertical asymptote, we can see that we are approaching negative infinity. So it is more specific to say the limit as x approaches 1 from the right is negative infinity. That limit also does not exist. Okay, number 2, same one, but we're going from the right. So it's the same function, so we know that the limit does not exist. And we can do a quick sketch of that to see what the graph is doing to the right of 1. And so we'll make a quick XY chart going to the right of 1, which means we're going to plug in 0 and negative 1. So if we plug in 0, we'll get 0. And if we plug in negative 1, we will get 1 plus 3 over negative 2. So we get negative 2. So 0, 0, and negative 1, negative 2. And so we can see that this side must be going up to positive infinity. So again, the limit does not exist. More specifically, it's going to positive infinity. Now, number 3 is not a one-sided limit. It is a two-sided limit. And so we know that when we plug in 0, or we plug in 4, we're going to get a 0 in the denominator. A 0 in the denominator means there's a vertical asymptote. And so we want to know actually what's happening on both sides of 4. And so we're going to plug in 5 and 6. We plug in 5, we're going to get 1. And we plug in 6, we're going to get 1/4. So 5, 1, 6, 1/4. So on the right side, we're going to positive infinity. And then we can also check the left side. So we're going to plug in 3 and 2. We plug in 3, we're going to get 1. And we plug in 2, and we're going to get 1/4. And so we're at 3, 1, 2, 1/4. So that side is also going to positive infinity. And therefore the limit as x approaches 4 from both sides is going to positive infinity. So another way to talk about limits is to know the basic shape of the graph. So if we're talking about the limit as x approaches negative infinity, we are basically just saying, what is the left arrow doing? Right? As x approaches negative infinity, that means what is the left arrow doing? Positive infinity is just saying, what is the right arrow doing? And so sometimes if we just know the shape of the graph, that's enough information. So we know x squared looks like this. And so the limit as x approaches positive infinity is saying as we go right, the function is going up to positive infinity. And then as x approaches negative infinity is saying as we go left, that left arrow is going up as well, so that is approaching positive infinity. X cubed looks a little bit different. X cubed looks like this. It's not a very pretty picture, but you get it. And so same question, as x approaches positive infinity, that's the right. F of x is going to positive infinity because the right arrow is going up. And then as x approaches negative infinity, that's left. The left arrow is going down to negative infinity. And then other graphs would be exponential growth, grows up and to the right. So the right arrow is going up to positive infinity. The left arrow is going towards 0, towards y equals 0. And then square root of x looks like this. And so as we're approaching positive infinity, the right arrow is going up to positive infinity. And as x approaches negative infinity, that does not exist because the graph does not go towards negative infinity. So that's just knowing the basic shape of the graph. So if we use that here, we can just get an idea because of what the graph looks like will give us the answer. So the limit as x approaches positive infinity of a square root function, really no matter where it is, but we know that this is left 3. But a square root function, whether it's moved left, right, up, or down, the right arrow is going up to positive infinity. So as x approaches positive infinity as the right arrow, this graph is going up to positive infinity. Number 2, limit as x approaches negative infinity of 3x squared. So again, we just know what x squared looks like. Ooh, not down. X squared, 3x squared is just skinny, but looks like this. So as we approach negative infinity, as we go left, that arrow is going up to positive infinity. All right, number 3, we're looking at the left arrow, x approaches negative infinity, of this line, negative 2/3 x. So a negative line, a line with a negative slope, is going to go this direction. which means that left arrow is going up to positive infinity. And then 4 to the x, we know that's an exponential growth. And so that left arrow there is going to 0. So one way to do it is to think about it graphically, okay? Another way is what you already know about horizontal asymptotes. So if the degree of the numerator is less than the degree of the denominator, then the limit is 0. So this is Bobo, bigger on bottom, the limit is 0. Okay? Bigger, or if they're the same, what do we say? Eats DC. Exponents are the same. Divide coefficients. So if they have the same as we do right here, the biggest exponents are the same, then the limit is 2/7 because it is the same as the horizontal asymptote. The horizontal asymptote is the end behavior of the graph. And then bottom is bigger on top. There is no horizontal asymptote, but there is an arrow. So this is saying, what is the right arrow doing? And we have to do a little bit extra thinking to figure it out. And so the easiest way is to just take that beginning and just kind of think about what that would be. So this is the only part of the graph that's really determining what the limit is. So this is similar. If the degree on top is 1 bigger, we are just talking about it's following the same pattern as 4x/3 because the degree on top is just 1 bigger. And that is a positive slope of a line. And so the right arrow is going up to positive infinity. And we'll do a lot more work with that. So here's your refresher. Bobo Bottom eats DC. And then here are some examples. So number 5, as x approaches positive infinity, that is saying, what is the right arrow doing? And the degree on bottom is bigger. Bigger on bottom, that right arrow is going to 0. Number 6 is also asking about the right arrow, but this one has the degrees that are the same. And since the degrees are the same, there's a horizontal asymptote at 2/3. And so that right arrow will be approaching 2/3. It'll be approaching that horizontal asymptote. Number 7, the right arrow, as x approaches positive infinity, the degree on top is bigger. And so this has no horizontal asymptote, but that right arrow is going somewhere. So we can't just say the limit does not exist because that right arrow is definitely going somewhere. If it's not approaching a specific value, then it's going up or going down. And so we ignore the rest of it and we just look at that beginning. And 2x cubed over 3x squared would reduce to 2x/3, which is just a positive line, which is going to positive infinity. The right arrow will be going to positive infinity. And then the same one, except we're going to talk about the left arrow here. And again, bigger on top. There is no horizontal asymptote. And so again, this reduces now to 2x/3. And so we'll perform the same way. And so that left arrow is going down to negative infinity. If there are other weird functions within there, you want to know that an exponential function, 2 to the x, is the most powerful. That will go to positive or negative infinity the fastest. And therefore, that overpowers any of these other ones. Okay? X to a higher power will go to infinity faster than x to a lower power, but slower than an exponential. Exponential grows the fastest. That will go to infinity the fastest. And so that will overrule these other functions. And then a log function, that moves so slowly. If you remember, a log looks like this. A log graph looks like this. So that very, very, very slowly will approach positive infinity. And so that doesn't hold a lot of weight, okay? So here we have other functions mixed in there. So note there that Delta Math just says does not exist. It does not specifically determine positive or negative infinity. Okay, so on number 9, the most powerful thing, we have the degree on bottom is bigger. However, this negative 4 to the x is more powerful because exponentials are the most powerful functions. They go to infinity or negative infinity faster. So they determine where this graph is going. All right, and we know that 4 to the x is an exponential growth. And so negative 4 to the x is a negative exponential growth. So that's flipped upside down. And so that right arrow is going to negative infinity. It's going down. All right, number 10. Again, we have the degree on bottom is bigger. But we also have this natural log. A natural log is the same as a log, right? So natural log is just a log, not very powerful, and therefore our exponents are the most powerful. So bigger on bottom is overruling everything else. And so we know that that is going to 0 because we're using our horizontal asymptote rules. Number 11, 4 to the x is the most powerful, and 2 times 4 to the x is the most powerful. So these things don't affect the limit very much. And so we actually have the same power on top and bottom. And then just like horizontal asymptotes, we just go to leading coefficient over leading coefficient, which is 1 over 2. All right, then number 12, the last one here, logs are not very powerful. X to the 500 goes to infinity pretty quickly. E to the x, though, is an exponential, and an exponential overrules all power functions. And so e to the x is the most powerful. E to the x is like 2 to the x, 2 point something to the x, and so that is going to positive infinity. That is exponential growth. And so this right arrow, as x approaches positive infinity, the right arrow is going up to positive infinity. Okay, so a little summary here is if you get a 0 in the denominator, the limit does not exist, and there is a vertical asymptote. Okay, and then you want to see if you can be more specific. So if we want to try to graph what this is here, the limit as x approaches 3 of f of x is infinity. That means there must be a horizontal asymptote, or not a horizontal, a vertical asymptote, sorry, a vertical asymptote at 3. And both sides are going to positive infinity. So we don't know what else is happening, but we do know right here on either side of 3, the graph is going to positive infinity. If you have the limit as x approaches infinity is 3, so notice the difference in these two, that means the right arrow goes to 3. X approaches infinity means the right arrow is going to 3. That means there's a horizontal asymptote at 3, and the right arrow is approaching that, either from on top or it could be on the bottom. We're not sure. It could also be down here. That would be an acceptable answer. So that's just a little summary. And now I want you to go ahead and stop the video and there's 4 here and another couple here. So go ahead and stop the video now, do those, and I will post the answers in Schoology. Thanks.